I'll be discussing volcanoes. Volcanoes are one of Earth's most dynamic and powerful natural features. They're openings in the Earth's crust that allow molten rock, gases, and ash to escape from the below surfaces. I'll be exploring more about what causes this phenomenon and dive into the science behind volcanoes, and first I'll be starting with the role that plate tectonics plays in their formation. Volcanoes are closely correlated with plate tectonics, and most of these volcanoes form at the plate boundaries where these tectonic plates interact. At divergent boundaries, for example, like the Mid-Atlantic Ridge, magma tends to rise and fill the gap as the plates pull apart, while at convergent boundaries, like the Pacific Ring of Fire, previously mentioned, oceanic plates subduct beneath these continental plates, where creating the magma that fuels these explosive volcanoes. There are also a lot of hotspots like Hawaii, where a lot of magma rises through the mantle and forms these volcanoes around these plate boundaries. I'll be discussing the 4 types of volcanoes, first starting with shield volcanoes. They are broad in size and they have gently sloping mountains, and their magma type is basaltic, which is low silica and low viscosity. Their eruption style usually has lava that flows at long distances, and the eruptions are usually just lava flows and a little bit of ash. Another type of volcano is a composite volcano, and these tend to be steep and symmetrical. Their magma type is andesitic to rhyolitic, and the eruption style tends to be very explosive, with many alternating layers of lava, ash, and other volcanic materials. The third type of volcanoes are called cinder cones, and they're small and steep-sided cones, and so their magma type tends to be basaltic to andesitic, and it also has a very explosive eruption style, but it's very short-lived, and there are lava fragments that get projected, and so it tends to produce cinders and ash and other volcanic bombs. The last volcanic type we'll be discussing are dome-shaped mounds, and these have rhyolitic magma types. The eruption style tends to be very slow, because the lava piles up at the top of the vent, and this usually produces like a blocky lava flow and ash as well. Each of these volcanoes represents a different magma composition, eruption style that all create unique landforms and hazards. Because these explosions can tend to reach very far, there's a lot of hazards that are combined with volcanoes. Explosive eruptions specifically can produce pyroclastic flows, which are just fast-moving clouds of hot gas and ash, and these can be super destructive, as well as destructive mud flows. The ashfall from these volcanoes can also disrupt air travel, damage infrastructure, and volcanic gases like sulfur dioxide can harm people's health and even affect the global climate as well. The most at-risk locations tend to be areas near the volcanoes or near the vent, because they're at risk for the pyroclastic flow and lava flows and other volcanic bombs. Also, any like valleys or drainages are prone to a lot of like mud flows during any heavy rainfalls, any downwind areas as well, where the ash can travel long distances and disrupt people's daily lives. Coastal zones are another super big area, especially if the plate tectonics are moving, because there's a risk of tsunamis, especially if an eruption causes a landslide or a caldera collapses. And it's super important to understand these hazards so that we can be prepared for them, and we can do a lot of risk assessment, data collection, and hopefully get ahead of when these volcanoes erupt, so that communities near these volcanoes have the opportunity to evacuate. There are multiple interesting features that volcanoes create, like calderas, like the one at Yellowstone, or lava plateaus, which can be created from repeated fissure eruptions, or volcanic islands is a really cool one where they emerge from the ocean as magma rises to the surface. And so it's just super interesting to see the kinds of land masses that volcanoes can produce. It's important to predict when these volcanoes are going to erupt, because it can save lives, and especially when we're monitoring these volcanoes scientifically, we're looking for any activity of earthquakes that might come before eruptions or any deformation. Scientists tend to use a lot of GPS and satellites to look for any sign of activity like swelling or sinking. Any gas emissions as well, or thermal imaging can provide clues as to a eruption possibly occurring. So although the exact timing can't be predicted, we can predict when an active volcano might erupt, and this is just extremely pivotal in making sure that those communities have the opportunity to evacuate. It's also important that we note that volcanoes can also impact the global climate. Because these large eruptions are releasing sulfur dioxide, it can form aerosols in the stratosphere, which reflects sunlight and cool the earth. And it's super interesting to see how that can cause an influential shift in climate and temperatures as well. There are benefits to those communities living near these volcanoes, like fertile soils or even geothermal energy. So it can technically balance out the risk, but like I said, it's very important that we get ahead of predicting when these volcanoes are going to erupt. By studying volcanoes, we gain insight into the past, present, and future. There have been a lot of notable volcanic eruptions in history, and so we just have to learn to coexist with these global land formations because they will continue having an impact on our livelihoods and our climate. And it's just important that we learn how to assess the risks and then assess the potential consequences as well so that we can work around it and provide humanitarian aid for those who need it. And I just love to think how interesting it is that the shifting of tectonic plates can cause a lot of natural disasters. And so it's interesting that volcanoes are one of them, and that there are so many different types of volcanoes that can result from the shifting of the plates and the moving of the magma.